The Grenton Academy, Part 8. Configuration of the Smart Home System Heating. Good morning. My name is Marek Pollitt and I invite you to the next part of our training where you will learn how to control heating in the smart home system. Traditional heating in a typical house will look like the diagram shown. There is a boiler here, which through the distributor provides heat to radiators mounted in the particular rooms. As a rule, in the central point of the house, a thermostat will be mounted, i.e. the wall controller that will control the operation of the entire system. To put it simply, if the temperature around this controller drops, it will send information to the boiler and start heating. When the temperature is reached, the controller sends to the boiler the information, turn off heating. Due to the construction of the house, its layout in relation to the terrain or geographical directions, room temperature in the entire house will not be the same. There will be rooms where the temperature will be higher and some where it will be lower. Therefore, in a central heating system, in a system based on a central controller, some of the rooms will be overheated, while some others may be underheated. There is no possibility of precise temperature control in each room, which results in heat losses, i.e. simply energy losses. A frequent disadvantage of this type of solution is also the lack of remote control capabilities, i.e. you simply won't be able to control such a system from your smartphone. In modern construction, in modern houses, a slightly different heating system is already used. I mean here zone heating. You can see what it looks like here. Next, here is a heating boiler which through the distributor provides you with the heat to individual rooms, while the temperature is measured in each room separately. In addition, there is an actuator mounted on the distributor for each heating loop. How does this operate? At the moment, when in one of the rooms the temperature drops, the actuator will open and provide you with heat, but only to that given room. When the temperature is reached, the actuator will close and cease providing heating, but only to that given room. The temperature will be individually controlled in each of these rooms. What does this ensure? First of all, the temperature in each of the rooms can be controlled separately in a very precise way, which allows us accurately to adjust the heat demand to the characteristics of the house. Another issue is the ability to create schedules for each of the zones separately. There are rooms in a house in which you stay more often, less often, or in which we stay at certain times of the day. And you can adjust the heating schedule so that the temperature in these rooms is comfortable when you're in there. In the remaining hours, you can lower the temperature a little to save energy needed to heat the house. Another issue is the ability to control this temperature from a mobile application. For each of these rooms, you will be able to remotely manage the temperature, i.e. when you're at work, on vacation, away from home, you will be able to check the current temperature, raise it, or change the schedule for those zones that you actually want. The possibility of combining such a heating system with other elements of the system also is a great advantage. If you have an alarm installed in the house, the moment you leave and arm the alarm system, the heating system can be automatically lowered in the whole house or in selected zones, selected rooms. What devices do we need to control the heating in that way? First of all, you need this element that will cut off the heat supply, i.e. a thermoelectric actuator. Such an actuator can be mounted on both the radiator and the distributor. In a situation where there is an underfloor heating system, such an actuator will be installed on the manifold for the underfloor heating. The next elements needed are the control modules of the Grenton system. The CLU module is needed for such a system. That will be module configurations are stored and virtual thermostats created. And after connecting it with a Wi-Fi router, it will allow you to remotely access the system from mobile applications. The next module needed is the relay output module, to which the actuators or our solenoid valves will be mounted. You can use, for example, the I/O8/8 module, which has as many as 8 relay outputs, i.e. it will allow us to set up to 8 individual heating zones, and which is additionally equipped with 8 potential free inputs. To these inputs you can connect, for example, traditional lighting switches, if the system in addition to heating also controls lighting, or for example window opening sensors. Thanks to this, when somebody opens a window in a given room, in that room the heating will be automatically turned off. The final element you need is the temperature measurement. You can carry out temperature measurement in 3 ways. First, you can use Dallas DS18B20 sensors for this. Such a sensor can be hidden, for example under the light switch, and thus the temperature measurement will be carried out. In order to connect this type of sensors to the system, you will need another module on the control module side, analog/in/out module. Such a module allows you to connect up to 16 Dallas DS18B20 sensors to the system. Our touch panels are also equipped with the temperature sensors, so if you decide to install touch panels in a given room, you'll be able to use the machine to control heating in that room, in that particular zone. The last element on the system side that can be used to measure the temperature is the Grenton Smart Panel. It, like our touch panels, has a built-in temperature sensor, but also has an LED display on which you can display a thermostat to control the temperature in that zone. See now what an example of such a control system looks like. We start building the system from the CLU module. At the very beginning there is a CLU module that will store the configuration, and after connecting it to a Wi-Fi router will allow you a remote access from your mobile applications. Then you connect the I/O module out of the bus of this module, to which the heating actuators will be directly connected, and next to the bus via the bus module you will connect control panels mounted in each zone separately. As for the cables that will be used, to connect the CLU to the router, of course, a typical computer cable will be used, i.e. UTP 4x2x0.5 millimeters. However, a typically electric wire will be used to connect the heating agitators. Touch panels and control panels are connected with a Grenton Smart Home cable 2x0.8 main cable arranged in serial topology. As you remember from the previous training videos, the system presented in the previous diagram can be further expanded with boiler control. Earlier, you controlled the receivers, i.e. we controlled the heat supplied directly to the radiators or the floor heating loop. You can also connect a boiler controller to such a system, so if you wanted the boiler to turn off when all heaters are closed, you must connect it to the system. It can be done in 2 ways. You can connect it via the so-called thermostat input. Most boilers I know have this input. Through one of the relay inputs, you can now say to the boiler, turn off, or turn on. Or, if the boiler used in your installation has a communication interface which allows you to more complex integration, then you can connect such a boiler through a suitable gateway. For example, it can be a gate mod bus or gate HTTP. If the boiler is connected directly to the relay output, you can only start its operation, switch it on and off. In the case of boiler integration using integration interfaces, in addition, you will often be able to receive some information from the boiler, for example, on breakdowns. Since you already know what devices will be needed to control the heating system, let's move to the configuration. Configuration in the system will be based on virtual objects, a thermostat. For this purpose, you can create 64 such thermostats, i.e. it will allow you to control the work of up to 64 heating zones. It can be said that virtual thermostats correspond to those wall controllers that are mounted in rooms, what you saw in the first diagram. However, our thermostats have much more extensive functions, including a number of functions that can be used when creating a more complex configuration such as heat up functions, i.e. timely heating, holiday mode, the ability to change the heating direction. For example, it's possible to control both heating and cooling in a given thermostat area. Let's move on to configuration. Now you can see that the project that was created during the previous training parts, and we are going to create thermostats in this project to control 2 heating zones. To control the heating in the living room and in the kitchen. We start by selecting the CLU module on which we want to create the virtual thermostats. It is best that it is the CLU on which there are temperature sensors for the heating zones. Then select the Add Object button from the top menu. We select the object thermostat from the list and name it. My first thermostat will control the temperature in the living room. Thermostat _ living room. Then, as the source, we indicate the temperature sensor from this zone, i.e. from the living room, and as the receiver, the heater that will be installed in that zone. So the thermostat is already created. Now you can set the temperature for this zone in the schedule. You can see what it looks like. Of course, I set this temperature now, for example, but you can do it more precisely. You can set it for each of the days separately. You can also set temperature for several days in groups. For example, you can select several days, for instance, and set all the temperature here for all those days. You can see now what it looks like. The temperature can be set in resolution every 15 minutes, so you can very precisely determine at what hours what temperature will be set in a given zone. Okay, the thermostat was created. I immediately create a thermostat for the second zone, the kitchen. So again, I select the thermostat object from the list, enter thermostat _ kitchen, or name for this thermostat, and this time I will indicate the temperature sensor installed in the kitchen, and as the receiver, the radiator, which is exactly installed in the kitchen. And here, just like before, you can set the temperature in the hours you will be there. It can be individually set for each zone separately. Okay, after creating this thermostat, you send the configuration, and at this point, after sending the configuration, this thermostat is already working. You will see in your systems that at this point the outputs will be turned on or off depending on what temperature you set. But if you would like to be able to control the temperature or set this temperature, let's assume, for example, from the level of the Grenton Smart Panel, there is the Smart Panel list, all its buttons, and you can see here that it has 4 pages defined in advance, and you will set the thermostats on the display of this Smart Panel. But before we get to the thermostats, let's set lighting control on the first page. So that's our interface. It was a bit more interesting. To do this, go to the Smart Panel page object, select page 1, i.e. panel page 1, go to the built-in features, and then select the page type feature. You choose the type of buttons, set the name of that page as, say, lamps, and now you need to activate the buttons. Enter the ID for the buttons, i.e. it will be 1, 2, 3, 4. In this way, you define whether these buttons should work separately, or for example, you want to group them. or which button has which function to perform. Once you have activated the buttons and assigned them an ID, you go to the button configuration, i.e. you do it in exactly the same as you did during the lighting configuration. You choose the button you want to configure, choose what it has to control. Let's say the button will control the lamp, so see now, you can group the objects in the menu by type. They can be inputs or outputs to make the configuration a bit easier. The first button controls the lamp in the kitchen. We will choose the switch method. So now we set the signature for this button. Let's start with the signature. We simply enter the name of this lamp, meaning kitchen, and this name will then be displayed on the touch panel. We go to the next button, button 2, and analogously we choose what we want it to control. For example, let's say an LED lamp in the bathroom. We also choose the switch method, and also here we enter the name. Please note that I use Polish characters here and the system allows for it. In the case of the label feature, what will be displayed on the panel, you can use Polish characters. The next button 3 will control the dimmable lamp. We will choose lamp underscore living room underscore dimmable and also use the switch method. But here in the built-in features, instead of entering the label, we choose an icon. To the icon A feature, I will enter the name of the icon that I chose earlier. It will be, for example, a lamp to off icon. You can see the list of icons and what they look like in the datasheet for the smart panel. And we still have button 4. In my case, button 4 will be used to start the scene, i.e. the script. I choose the script, let's say it will be a scene, turn it off, and here I will also use the icon for marking. Let it be a snide icon. We already have set up the first page of our smart panel and it will display icons to control lighting. So let's get to the thermostats now on the second page, and again we go to the panel page 2 object, go to built-in features, change page type to thermostat mode, write the name of this page as heating, now to add a thermostat to the page we need to know its object ID. Where do we get that from? We open this thermostat and now you can see that it has the ID of our thermostat. We press Ctrl C, copy, and then paste it in the place where the ID is. And enter the name that will be displayed on the screen of the smart panel, living room. I would like one smart panel to simultaneously control the thermostat in the living room and the kitchen, and exactly the same as we did before. I open the thermostat underscore kitchen, copy the ID of this thermostat, go to the panel object page 2, and paste the object ID and give the name that will be displayed. Because on the same smart panel, 4 thermostats can be controlled on one side, i.e. there can be as many as 16 on 4 sides of those thermostats. So you can use one smart panel to control thermostats in 16 zones. I send the configuration to the CLU module afterwards, and immediately after sending this configuration, my system reboots after sending the configuration, and now you can see how it works. Can you see now? Page 1 was displayed on the screen where I have 2 labels that I have signed. You can see how it works. I wave my hand change sides and have my thermostats. The living room thermostat is displayed first, but with this button you can switch to the kitchen thermostat. See? The thermostat in the kitchen is turned off. The condition is off. If I hold this button for a longer time, it changes into auto, but if I change the temperature plus minus, it goes into manual mode. But with the button, I can change it to auto again. Auto means that the thermostat is in a schedule mode, i.e. the temperature it will seek will be in accordance with the schedule we set. Manual mode means that it will go to the temperature that you set with the buttons and will keep it permanently. Fine. In that case, since I already have my thermostat on the smart panel, then in the next step, let's prepare the interface for the application for smartphones. I come back to the Object Manager. At the bottom, you see the interface. I will open it now. See? Now the thermostats that have been created are marked. Switched to the heating page. Here, of course, the name can be changed to one that will be more friendly and readable. I will change the names to the abbreviated ones, and then I will send the interface. i.e. at this moment I am starting the myGrenton application on my smartphone. I add a new interface, scanning the QR code, and I can now go to the tab with heating and see I have now exactly the temperature I've set. One of the thermostats works in manual mode and the other one in schedule mode. By clicking, I can also change these modes, i.e. by clicking on the temperature value, I can go to the schedule, edit the schedule, or change the mode of the schedule. Thank you very much for your attention, and I invite you to the next training videos where you will learn how it's possible to configure the operation of blinds in the smart home Grenton system. Goodbye.